Hello student, welcome to my channel Learn More Maths by Vara Kumar. Today we are going to start a new chapter, progressions. Very important chapter student. From this chapter also you can get each type of question in the examination. A 1 mark question, 2 marks question, 4 marks question and objective type. At least you get 10 to 12 marks from this chapter. Sometimes he asks 2-4 marks questions from this chapter. So very easy and important student. So what we learn in this chapter? Progressions. In this progressions we have two types of progression student. Number one is arithmetic progression. Arithmetic progression, and we have second one is geometric progression. Arithmetic progression, and number two is geometric progression. Geometric progression. So we have these two progression in our syllabus student. It is denoted by GP, and arithmetic is progression is denoted by AP. So by its first letters, arithmetic progression, it is denoted by capital AP. Geometric progression, it is denoted by capital GP. So first we have to learn about arithmetic progression. So what is arithmetic progression? So before that student, I am writing some list of numbers here. See 2, 5, 8, 11 and so on. So next one more list of numbers, 3, 7, 11, 15 and so on. So one more student, 20, 10, 0, minus 10 and so on. So next student, one more, 5, 5, 5, 5 and so on. So next one, 6, minus 6, 6, minus 6 and so on. So student, I have written some lists of numbers here. So you have to observe, is there any relation between between successive terms or successive numbers in the given series. So first I am taking the first series, first list of numbers. What it is student? 2, 5, 8, 11. So you have to observe. So the list, the numbers involved in the series are called the terms here. So the numbers involved in the series are called terms. So you observe first term, this is known as the first one, first number just. So it is 2. So it is 5, 8, 11. So is there any relation between the successive number student? 2 after 5. So if you add 3 to the 5, if you add 3 to the 2, you can get 5. In the same way, if you add 3 to the 5, you can get 8. Again, if you add 3 to the 8, you are getting 3. So by adding 3 to the adding 3 to the preceding term, we are getting the next term. So next, taking the second list of numbers. So 3, 7, 11, 15 student. Again you have to observe, is there any relation between the two successive numbers? First take 3. If you add 4 to the 3, you are getting 7. Again if you add 4 to the 7, you are getting 11. Again if you add 4 to the 11, you are getting 15. So here by adding 4 to the preceding number, we are getting the next number. So is there any relation between 20, 10, 0, minus 10 is there student. Here it is 20. So next number is 10. So by adding minus 10 or subtracting 10, or by adding minus 10 we are getting 10. Again minus 10 we are getting 0. Again minus 10 we are getting minus 10. So in the same way 5, 5, 5. So there is nothing added. So just simply 0 is added to the preceding term to get the next term. So here what is student? 6, minus 6, 6, minus 6 and so on. So is there any relation between the terms? So see here it is 6 minus 6 is there, like again 6 is there, again minus 6 is there. So here we are not getting by adding or subtracting. So if you add 1, here you can get 7. If you subtract 1, here you can get 5. But here 6 minus 6. Except this, all this, in all the lists of numbers from 1 to 4, a fixed number is added to get the next number except the first number. So these list of numbers are called arithmetic progressions. So how can we define, see student, definition. So definition of arithmetic progression. So an arithmetic progression is a list of numbers in which each term is obtained by adding or subtracting, whatever, by adding a fixed number to the preceding number except the first number. So or we can say these are the terms. So the numbers involved in the list are called the terms. So how can we define? See student, arithmetic progression is a list of numbers. It is a list of numbers like this. All these are lists of numbers. Arithmetic progression is a list of number. Arithmetic progression is a list of numbers in which each term or each number is obtained by adding a fixed number to its preceding number except the first number. So see student, this is the definition. How can we define? So arithmetic progression. So how can we define, see student? Arithmetic progression is a list of numbers. Arithmetic progression is a list of numbers. A list of numbers. It is a list of numbers. Yes, like this. In which each number is obtained. Each number is obtained by adding a fixed number. By adding a fixed number to its preceding number, except the first number, So this is the define. How, like this we can define the arithmetic progression. See student, what it is, a definition. Arithmetic progression is a list of numbers. Yes, all these are list of numbers in which each number is obtained by adding a fixed number to its preceding number except the first number. So these are the arithmetic progressions. Since all these are lists of numbers in which each number obtained by adding a fixed number to its preceding number except the first number. So all these are the examples of arithmetic progression. So this is example 1, this is example 2, example 3 and example 4. But this is not an arithmetic progression. So student, the fixed number which is added to the preceding term is called the common difference. So the numbers in the list are called the terms here. The numbers in the list are called the terms. So see student, the numbers involved in the numbers involved in the list are called terms. In the list are called terms. So what are these are called? So these are the numbers involved in the list. These are called terms, student. This is the first term, second term, third term, fourth term and so on. So the numbers involved in the list are called the terms, and the fixed number which is adding to the preceding term, so this fixed number is called the common difference. So the fixed number is called the common difference. So the fixed number is called The fixed number is called common difference. The fixed number is called common difference. What it is, student? Common difference. So it is denoted by small d. The fixed number is called common difference. It is denoted by small d. It is denoted by small d. So here in an arithmetic progression, so it is denoted by AP. Simply it is denoted by AP. In an arithmetic progression, so in an arithmetic progression, so if the first term is A1 and the second term is denoted by A2, third term is denoted by A3 and so on, the nth term is denoted by AN. So in an AP, first term is A1, first term is A1, comma, second term is A2, second term is A2, comma, third term is A3, third term is A3, comma, dash dash, nth term is AN, nth term is AN. Then therefore the AP is A1, comma, A2, comma, A3, comma, dash dash AN. So this is AP, student. So if the first term is A1, second term is A2, third term is A3 and so on, dash dash, the nth term is AN. So this is AP. So the general form of an AP is denoted by, so the general form of an AP, the general form an AP, the general form of an AP. So the general form of an AP, AP means arithmetic progression, is A, comma, A plus D, comma, A plus 2D, comma, A plus 3D and so on. So this is the general form of an arithmetic progression, student. So now we have to learn how can we write the terms in the arithmetic progression, that we have to learn. This is the general form of an arithmetic progression, student. Now here A is the first term and D is the common difference. So A is the first term, student. A is what? A is the first term. A is first term and D is what, student? D is the common difference. D is the common difference. D is the common difference of AP. So A is the first term, D is the common difference. So here first term A, second term A plus D, third term A plus 2D, fourth term A plus 3D. So first term A is known as the first term and the D is known as the common difference. So see, student, now we have to write the terms in the AP. So first term, it is denoted by A1. So now I am writing clearly. First term, it is denoted by A1, which is itself A, student. And second term is denoted by A2. How can we get A2, student? By adding difference, common difference to the first term. A2 can be written as A plus D. Just you have to observe, student. In the same way, third term is denoted by A3. How can we get, student? By adding D to the second term. Again by adding D to the second term. So here already A plus D is there. A plus D plus D, that is A plus 2D. This is the third term. In the same way, fourth term, it is denoted by A4, student. How can we get? By adding D to the third term. A4 we can write A3 plus D, A3 plus D, that is A3 is A plus 2D plus D, that is A plus 3D. So fourth term is A plus 3D. So in the same way, I want to write the 10th term, student. How can I write 10th term? 10th term, A10 is equal to, by observing all this, if A1 it is A only, if A2 it is A plus D only, A3 A plus 2D, for A4 A plus 3D, for A10 it is A plus 9D, A plus 9D. I want to write 20th term, student. 20th term. So it is denoted by A20. So how can we write, student, 20th term? It is A plus 19D. A plus 19D. So in the same way, I want to write nth term. Nth term. So can you say, student, how can we write? Nth term is denoted by An. So see, student, if it is 20, A plus 19D, 1 less than 20. If it is A10, A plus 9D, again 1 less than 10. If it is A4, A plus 3D. So in the same way, we can write A plus 1 less than N, that is N minus 1 into D. This is An. So this is known as the general form of an nth term. This is known as nth term or the general term. So this is the general term of an AP. General term of an AP. General term of an AP. So the general term of an AP, An is equal to A plus N minus 1 into D. Sometimes it is also known as the last term, student. You have to remember, it is also known as the last term. It is denoted by small l. So the general term of an AP, An is equal to A plus N minus 1 into D, and the last term L is equal to A plus N minus 1 into D. So in both the ways we can call it is, student, either general term or the last term. So this is the introduction of arithmetic progression, student. So in an arithmetic progression, there are two types of arithmetic progressions, finite and infinite. Suppose, see, student, if there is a list of numbers, what I have written in the first, 2, 5, 8, 11, dash dash. So see, student, it is a list of numbers. We have to check whether it is an AP or not. So by finding the common difference in every successive terms, we can get the common difference. We can say whether it is in AP or not. So here the difference is 3 in every 2 successive terms. So therefore it is in AP, but there is no last term here. There is no last term. So this AP is called infinite AP. Infinite AP. Infinite AP. This is called infinite AP. Suppose if there is no dash dash, if there are, so this is infinite AP. So I am writing, so student, one more, 2, 5, 8, 11, that's all. So this is finite AP. There is a last term in the given AP. This is finite, this is infinite. Suppose if there is dash dash dash, suppose there is 54 here. So here there is a last term. It is also finite, student. So that is the difference between infinite AP and finite AP. So next we have to learn the common difference. How can we find the common difference? So here common difference D is equal to difference between any two successive terms, that is A2 minus A1, A3 minus A2. Common difference D can be found like this. D equal to A2 minus A1, which is equal to A3 minus A2, that is A4 minus A3, that is equal to dash dash. So like this we can find the common difference. So this is the introduction of arithmetic progression, student. Now we have to solve some problems related to the introduction of arithmetic progression. See, student, here we have to solve problems related to the arithmetic progression. So in exercise 6.1, first problem he has given. See, student, what he is asking: in which of the following situations does the list of numbers involved make an arithmetic progression and why? So first one, the taxi fare after each kilometer, when the fare is rupees 20 for the first kilometer and raises by rupees 8 for each additional kilometer. So this is the situation. So student, in exercise 6.1 first problem, he has given some situations. So whether the numbers involved in the situation form an arithmetic progression or not, he is asking. So first we have to write the list of numbers involved in the given situation. So then after we have to check whether it forms an AP. How can we check? By finding the common difference of every successive term. So we can say if the common difference is same in each successive terms, then we can decide the list of numbers involved in the given situation forms an arithmetic progression. Otherwise it doesn't form an arithmetic progression. So see student, now this is the situation he has given to us. So what it is, just again I am reading. The taxi fare after each kilometer, when the fare is rupees 20 for the first kilometer and raises by rupees 8 for each additional kilometer. The fare for first kilometer, the fare for the first kilometer, the fare for the first kilometer is equal to rupees 20 student. For fare for additional kilometer is rupees 8. Fare for each additional kilometer, fare for each additional kilometer is equal to rupees 8. So for the first kilometer it is 20 and for each additional kilometer is rupees 8. For 2 kilometers how much student? For 2 kilometers fare equal to, for first kilometer it is 20 and the next kilometer it is 8. 20 plus 8 which is rupees 28. And for 3 kilometers how much student? For 3 kilometers fare is equal to rupees 20 for the first, again 8 for the second, again 8 for the third. So it is 36. 20 plus 8 is 28 plus 8 is 36. Therefore the list of fares equal to rupees 20, 28, 36 and so on. So here this is the first term, second term, third term and so on. Now we have to check whether it forms an AP. We have to find the common difference. A2 minus A1 is equal to 28 minus 20 which is 8. In the same way A3 minus A2 is equal to 36 minus 28, it is also 8. Therefore it forms an AP. Since the common difference is the same, it forms an AP. Since the common difference is same, since the common difference is same, it forms an AP. So since the common difference is same, so the given situation forms an arithmetic progression. So this is the first bit in exercise 6.1 first problem, first bit student. So next second bit. So student, this is the second situation in the first problem. So see student, what he has given. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So see student, so there is some air, some quantity of air in the cylinder. So if we remove the vacuum pump, 1/4 of the air flows out from the cylinder. So next again if we remove, again 1 by 4th from the remaining. So that he is saying, so let the quantity of air at the present, let the quantity of air be x, so whatever it may be, x liters or whatever it may be, x units, let the quantity of air be x units, whatever it may be. So for first time, if the vacuum is or removes for first time, so in the first time it is x, first time it is x. For second time, if vacuum opens, removes, it becomes x minus 1 by 4. Again vacuum opens, for third time it becomes x minus 1 by 4, again 1 by 4. So the list of numbers, the list of amount of air, the list of amount of air is x, comma, x minus 1 by 4, comma, x minus 2 by 4, it becomes, comma, and so on. So here, whether the list of amount of air forms an AP or not, we have to check. By finding the common difference of successive terms, we can decide whether it forms an arithmetic progression or not. So here A2 minus A1 is equal to x minus 1 by 4 minus x. So that is minus 1 by 4. In the same way, A3 minus A2 is equal to x minus 2 by 4. This is A3 minus of x minus 1 by 4. This is A2 student. A3 minus A2. So that is x minus 2 by 4 multiplied by minus x plus 1 by 4. These two gets cancelled here. Minus 2 plus 1 by 4, which is minus 1 by 4. So here the common difference is same. Since the common difference is the same, since the common difference is same, since the common difference is same, it forms an AP. It forms an AP. It forms an AP. So since the common difference is same, it forms an arithmetic progression. So this is the second situation, student, in the first problem. So next, third student, this is the third situation in the first problem from exercise 6.1. Student, see here, the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and raises by rupees 50 for each subsequent meter. So the situation, this is the situation he has given, student. He is asking to find us whether the list of numbers involved in the given situation forms an AP or not, and why he is asking. So first we have to write the list of numbers involved in the given situation. So students, see, now I am writing the list of numbers involved in the given situation. So the cost for digging a well he has given, student. For digging the well, the cost for the first meter, it is rupees 150. After the first meter, for every meter, the cost for digging the well is rupees 50 he has given. So the cost for first meter for digging the well, it is about digging the well, student, digging the well. The cost for first kilometer, the cost for first meter, sorry, not the cost for first meter, it is rupees 150. So rise in cost is rupees 50 for every meter after the first meter. So rise in cost, after first meter, for every meter. For every meter. So how much it is? Raise is rupees 50, student. So for digging the well, the cost for second meter, 2 meters, the cost for first 2 meters, the cost for first 2 meters equal to how much, student? It is rupees 150 plus rupees 50, totally it is rupees 200. And the cost for the first 3 meters, for first 3 meters, the cost for the first 3 meters equal to, for first meter it is 150, and for the second one it is 50, and the third one it is 50, totally it is rupees 250, student. So now the list of costs, the list of costs, how much, student? It is rupees 150 comma 200 comma, in the list of costs in rupees 250 and so on. So these are the numbers involved in the given situation, student. Now we have to check whether the numbers involved in the given situation forms an arithmetic progression or not. Now we have to check by finding the common difference. So here we have to check the common difference. First, A2 minus A1 is equal to 200 minus 150, which is 50. In the same way, we have to find A3 minus A2. So A3 is 250 and A2 is 200. 250 minus 200 is also 50, student. Now if you observe the common difference, it is the same. Since the common difference is same, it forms an AP. The numbers involved in the given situation forms an AP. Why? Since the common difference is same. So we can say, since the common difference is same, since the common difference is same, since the common difference is same, the given situation, it forms an AP, it forms an arithmetic progression, it forms an AP. Since the common difference is same, it forms an arithmetic progression. So this is the third situation in the first problem from exercise 6.1, student. Next we have to solve fourth situation. Student, here this is the fourth situation given in the first problem from exercise 6.1. So the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. So that he has given situation, student. Now we have to find the amount for after every successive years at 8% compound interest. So student, first we have to find the list of amounts. Then we have to check whether it forms an AP or not by finding the common difference. So student, here the principal amount is rupees 10,000. It is denoted by rupees 10,000. P is equal to 10,000. R is equal to 8%. So we have compound interest. Amount is equal to amount. A is equal to P into 1 plus R by 100 whole to the power n. So this is the formula, student. A is amount, P is principal, R is rate of interest, n equal to number of years. So here for every year we have to find, so n is equal to 1 here. So amount after 1 year or the first year, amount after 1 year. So let it is A1, student. A1 is equal to P into, so P is 10,000 into 1 plus R. R is 8, student. 8 by 100 whole to the power 1. So for 1 year n is equal to 1, student. So now it is see, student, how much it is? 10,000 into, find LCM, 100 plus 8, directly I am writing 108 by 100 student. So here 100 into 100 plus 8, 108 divided by 100. So these two zeros gets cancelled. We can get how much student? 100 into 108. So we can get 10,800. For the second year, this becomes principal student. That you have to remember in the compound interest. So this becomes principal for the second year. Amount after 2 years. Amount after 2 years is equal to, let it is A2 student, again P into, so this becomes principal for the second year, again 1 plus R by 100. Same student, here we have write 10,800 into, again here also 108 by 100 student. 100 into 100 plus 8, 108. Again these two gets cancelled. 108 into 108, we have to multiply student. Here I am multiplying 108 into 108. 8 8s are 64 student, 8 1s are 8. Again left 2 digits, 1 into 8, 0 1, 4 6 6 1 1. So 11,664 student. This is the principal for the third year student. Amount after 3 years you have to find again. Amount after 3 years. So let it is A3 student. So now this becomes principal for the third year. So that is 11,664 into 1 plus 8 by 100. So that is 11,664 into 108 by 100 student. 108 by 100. So now have to multiply 11,664 into 108. So then after we can make divide with 100. 8 4s are 32 and 3 student, 8 6 are 48 plus 3, 51 student, 1 and 5. 8 6 are 48 plus 5, 53. Again 8 1s are 8 plus 5, 13. 1 8 1s are 8 plus 1, 9. So next leave after 2 digits, right? 1 into 4 is 4, 1 into 6 is 6, 1 into 6 1 1. So 2 1 7 9 15 2 1. So divided by 100 is there student. It is how much? 1259712. That is 1259712 divided by 100. So it becomes 12,597.12. So see student, now have to write a list of amounts. List of amounts. List of amounts. So first it is how much student? 10,800, comma 11,664, comma 12,597.12, comma dash dash. So see student, it is very clear the common difference is not same here. So since the common difference is not same, the given situation does not form an AP. So see student, since the common difference is not same, since the common difference is not same, since the common difference is not equal, it does not form an AP. It does not form an arithmetic progression. Since the common difference is not equal, it does not form an AP. So see student, this is the fourth situation in exercise 6.1 first problem student. Student, by reading the situation, writing the list of numbers involved in the situation is very important student. So by reading the situation, we have to write the list of numbers involved in the situation. That is very, very important. He asks 4 marks problem. So by giving the situation. Student, this is the second problem from exercise 6.1. So see student, what he is asking, write the first 4 terms of the AP when the first term small a and the common difference small d are given as follows. So again there are some bits in the second problem student. Now I have to solve one by one. This is the first one. A is equal to 10, comma d is equal to 10. So both are 10 he has given. So what he is asking to find a student, write the first 4 terms. The first 4 terms are a1, comma a2, comma a3 and a4. These are the first 4 terms. So first term is a1 itself. A1 is equal to a, that is 10 student. Second term is a2. A2 is a plus d. A is 10 and d is also 10, that is 20. And the third term is a3. It is a plus 2d. A value is 10 plus 2 into d value is also 10, that is 10 plus 20 is 30. So see student, a3 is equal to a plus 2d. So a value is 10 plus 2 into d value is also 10. 10 plus 2 into 10 is 20. 10 plus 20 is 30. So fourth term, a4 is equal to a plus 3d, that is a value is 10 plus 3 into d value is also 10 student. 10 plus 3 into 10 is 30. 10 plus 30 is 40. So student, a3, a4 and a2, we can find this a3 like this. a3 is also equal to a2 plus d student. a3 is also equal to a2 plus d. So a2 plus d, a2 is 10 and d is 10. Sorry, a2 is 20 student. a2 is 20 and d is 10, which is 30. Like this we can find. So a4 also, a4 is equal to a3 plus d student. a3 is 30 plus d is 10, that is 40. So a3, like this we can find. So you can find using the formulas. These formulas are these. So these two are the different student. So these 4 are the first 4 terms. Therefore the first 4 terms are so what are the first 4 terms student? 10, comma 20, comma 30 and 40. So these are the first 4 terms student. So by using a and d values, we have found first 4 terms of the arithmetic progression. So this is first one in the second problem student. So student, this is the second bit in the second problem. He has given a equal to -2, d equal to 0. He is asking to find us the first 4 terms. So see student, how can we find? First term is a1, which is a only, is equal to -2. Second term a2 is equal to a plus d student, a plus d. So a value is -2, d is 0, -2 plus 0 is -2. Third term a3 is equal to, we can write a plus 2d, or it is also equal to a2 plus d. a2 plus d, in both the ways we can write, that is -2 plus 0 again -2 only. So a2 is -2, again 0, -2 plus 0. a4 is equal to, we can write a3 plus d student. a3 value is also -2, d value is 0, it is also -2. Therefore the first 4 terms are -2, comma -2, comma -2 and -2. So since the common difference is 0, all terms are equal here. So this is the second bit student in the second problem. So next third bit. A is equal to 4, D is equal to minus 3. A is equal to 4, D is equal to minus 3. Again we have to find the first 4 terms. So the first 4 terms are A1, A2, A3 and A4. So first A1 is equal to A only, it is 4. A1 is A, it is 4. And the second term A2 is equal to A plus D. A value is 4 plus D value is minus 3. 4 plus minus 3. So that is 4 minus 3, which is 1 student. In the same way A3 is equal to, we can write A2 plus D. A2 plus D. So A2 value is 1 plus D value is minus 3. A2 value is 1 plus D is minus 3. So it becomes 1 minus 3, which is minus 2. So next fourth term A4 is equal to, we can write A3 plus D again. A3 value is minus 2 plus D value is minus 3 student. So it becomes minus 2 minus 3, which is minus 5. So these are the first 4 terms student. Therefore the first 4 terms are the first 4 terms. The first 4 terms are, so what are the first 4 terms? 4, 1, minus 2 and minus 5. So these are the first 4 terms in the third bit student. So next we have fourth one. Student, fourth bit in the second problem. He has given A equal to minus 1, D is equal to 1 by 2. He is asking to find us the first 4 terms. The first 4 terms are A1, A2, A3 and A4. So we have to find those 4 terms. So see student, how can we find? So solution, A1, the first term A1 is equal to A only, it is minus 1. And the second term is A2. A2 can be written as A plus D. So A value is minus 1 plus D value is 1 by 2. So minus 1 plus 1 by 2. So finding LCM student, we can get minus 2 plus 1 divided by 2. Minus 2 plus 1 is 1 divided by 2. So this is A2. So next we have to find the third term. A3 is equal to A2 plus D student. So by adding common difference to the second term, we can get the third term. A3 is equal to A2 plus D. A2 value is minus 1 by 2 plus D value is plus 1 by 2. Minus 1 by 2 plus 1 by 2. We can get 0 student. A3 is 0. So next fourth term A4 is equal to A3 plus D. So by adding common difference to the third term, we can get the fourth term. A3 plus D. A3 we have 0 plus D value is 1 by 2. 0 plus 1 by 2 is 1 by 2. So therefore the first 4 terms are, the first 4 terms are, the first 4 terms are. Student, in the second method we can find A3 can be written as A plus 2D. So we have to substitute A and D values to get A3. So in both the ways we can find student. This is very easy. So the first 4 terms are, the first term is minus 1 and the second term is minus 1 by 2. Third term is 0 and the fourth term is 1 by 2. So these 4 are the first 4 terms of the given AP student. So next fifth bit in the second problem. So A is equal to minus 1.25 comma D is equal to minus 0.25. Again he is asking to find us the first 4 terms of the AP. So the first 4 terms are A1, A2, A3 and A4. So I have to find A1 is equal to A only, that is minus 1.25. So and the second term A2 is equal to A plus D. A2 is equal to what student? A plus D. So here A value is minus 1.25 plus D value is minus 0.25. So minus 0.25. So it becomes minus 1.25 minus 0.25. So plus into minus student. So minus 1.25 minus 0.25 is minus 1.50. This is the second term. So next third term a3 is equal to, we can write a2 plus d. By adding the common difference to the second term, we can get the third term. So a2 values we have minus 1.50 plus d value is minus 0.25, minus 0.25. So by simplifying, minus 1.50 plus into minus, we can get minus 0.25, minus 0.25. So here minus 1.75 student. Next a4 student. a4 is equal to a3 plus d. Again by adding common difference to the third term, we can get the fourth term. So a3 we have minus 1.75 plus d is minus 0.25, minus 0.25. So it becomes minus 1.75 minus 0.25. It is 0. So it becomes minus 2.00, minus 2.00. Therefore the four terms are, so what are the four terms? The first term is minus 1.25 and the second term is minus 1.50, third term is minus 1.75, and this is the first term minus 1.25, this is the second term minus 1.50, this is the third term minus 1.75, and this is the fourth term minus 2.00. So these are the four terms. By using a and d values we have found, student. So there are 5 bits in the second problem, student. These are the 5 bits. Student, now we have to solve third problem from exercise 6.1. This is the third problem, student. For the following APs, write the first term and the common difference. So there are 4 bits in the third problem, student. He has given the series. He is asking to write the first term and the common difference. Very easy, student. Very, very easy. So see, student, this is the given AP. So the given AP is, just we have to write the given AP is, given AP, student, 3 comma 1 comma minus 1 comma minus 3 dash dash. So he is asking to write the first term. First term is a1, which is a, that is 3, student, and the common difference is denoted by d, that is a2 minus a1. So a2 is 1 and a1 is 3. 1 minus 3 is minus 2. Therefore the first term equal to, the first term is equal to 3 and common difference equal to how much, student? Common difference is minus 2. Simple, student, very important and very easy. So this is first bit. Second bit, again he has given minus 5, minus 1, 3 and 7. So see, student, here this is the given AP. So first term a1 is equal to a, which is minus 5. So common difference d is equal to a2 minus a1. So here a2 is minus 1, student. A2 value is minus 1 minus a1 is minus 5. A1 is minus 5. So that is minus 1 minus into minus plus 5. Minus 1 plus 5 is plus 4. Therefore the first term equal to, so first term is minus 5 and the common difference equal to 4. So he is asking to write the first, he is asking to find the first term and the common difference. First term is minus 5 and the common difference is 4. This is second bit, student. So next we have to solve third bit. This is the third bit. 1 by 3, 5 by 3, 9 by 3, 13 by 3 and so on. So he is asking to find us the first and the common difference. First term and the common difference. So the given AP, this is the given AP. Here first term a1 is equal to a, that is 1 by 3. This is the first term. and the common difference D is equal to A2 minus A1. So student, not only A2 minus A1, we can find A4 minus A3 or A3 minus A2 or A2 minus A1. So we can find the difference of any two successive terms. So that is the common difference, student. Now I am finding A2 minus A1. So A2 is equal to 5 by 3 minus A1 is 1 by 3. So that is 5 by 3, this is 1 by 3. So by finding LCM, we can get 5 minus 1 by 3, which is 4 by 3. So 5 minus 1 by 3 is 4 by 3. Therefore, the first term is equal to, first term is 1 by 3 and the common difference is equal to 4 by 3. And common difference is equal to 4 by 3. So first term is 1 by 3 and the common difference is 4 by 3. So this is the third bit, student. Student, this is the fourth bit, 0.6, 1.7, 2.8, 3.9 and so on. He has given, this is the given AP. Again you have to find the first term and the common difference. So the first term is A1, which is A, that is 0.6, and the common difference D is equal to A2 minus A1. A2 minus A1. So here A2 is equal to 1.7 minus A1 is 0.6. 1.7 minus 0.6 is 1.1. Therefore, we have the first term is equal to, 0.6 and the common difference is equal to, 1.1. So like this we can find the first term and the common difference. Very easy, student. This is the third problem in exercise 6.1. So next we have to solve fourth problem. See student, this is the fourth problem from exercise 6.1. What he has given in the problem I am reading. Which of the following are APs? If they form an AP, find the common difference D and 3 more terms. So student, there are some bits in the fourth problem. I think there are 13 bits. So this is the first bit. So it has given 2, 4, 8, 16. So first we have to find whether it forms an AP or not. If it forms an AP, we have to find the common difference and the 3 more terms. So how can we check whether the given series forms an AP or not? By finding the common difference we can check. So we have to find the common difference, student. So this is the given AP, student. We have to find the common difference, that is A2 minus A1 is equal to, A2 is 4 minus A1 is 2, 4 minus 2 is equal to 2, student. In the same way, A3 minus A2 is equal to, A3 is 8 minus A1 is how much, student? 4 is equal to 4. So here A2 minus A1 is not equal to A3 minus A2. A2 minus A1 is not equal to A3 minus A2. So therefore it does not form an AP. It doesn't form an AP. It doesn't form an AP. So since the common difference is not equal, the given series doesn't form an AP. So if it forms AP, you have to find the common difference and the 3 more terms, but it doesn't form an AP. So this is the first bit, student. Next one more. So 2, 5 by 2, 3, 7 by 2 and so on. So first we have to check whether the given series forms an AP or not. So here again we have to find the common difference. A2 minus A1 is equal to, so A2 is 5 by 2, student, minus A1 is 2. By finding LCM we can get 5 minus 4 by 2, which is 1 by 2. So in the same way we have to find A3 minus A2. So A3 minus A2 is equal to, A3 is 3 minus A2 is 5 by 2. So A3 is 3 minus A2 is 5 by 2. Again by finding LCM we can get 6 minus 5 by 2, which is 1 by 2. So in the same way we have to find the next one. A4 minus A3 is equal to, so 7 by 2 minus 3, that is 7 minus 6 by 2, which is 1 by 2. So in all the 3 cases the common difference is same, therefore it forms an AP. It forms an AP. So if it forms an AP, the common difference is asking to find as a common difference D is equal to how much, student? 1 by 2. So then he is asking to find the 3 more terms. So how many terms are there, student, here? 1, 2, 3, 4. So that is A1, A2, A3, A4. So 3 more terms. We have to find A5, A6 and A7. So A5 is equal to how can we find, student? A4 plus D. So we have A4 is 7 by 2 plus D is 1 by 2. So we can get it totally 8 by 2, which is 4. 7 plus 1 is 8 by 2, 4. So next A6 is equal to A5 plus D, student. Again A5 is 4, D is 1 by 2. A5 we have 4 plus D is 1 by 2. So again we have to find LCM. 8 plus 1 divided by 2, which is 9 by 2. So next we have to find A7. So A7 is equal to A6 plus D. A6 we have 9 by 2 plus D value is 1 by 2, that is 10 by 2, which is 5. So therefore we have to write and 3 more terms are 3 more terms. So what are the 3 more terms, student? Here A5 is 4, A6 is 9 by 2 and A7 is 5. So these are the 3 more terms, student. So this is the first and second bits in fourth problem. Student, now we have to solve third bit. So student, this is the third bit in the fourth problem. So minus 1.2 comma minus 3.2 comma minus 5.2 comma minus 7.2 and so on is given, student. So first you have to check whether the given series forms an AP or not by finding the common difference of successive terms. So next if it forms an AP, you have to find the 3 more terms. So solution, how can we find? See, student, first you have to find the common difference. A2 minus A1 is equal to, so A2 is minus 3.2 minus A1 is minus 1.2. So that is minus 3.2 plus 1.2, it becomes minus 2.0. So in the same way, you have to find A3 minus A2 is equal to A3, that is minus 5.2 minus A2 is minus 3.2, it becomes minus 5.2 plus 3.2. So minus into minus plus, again it is also minus 2.0. In the same way, you have to find A4 minus A3 is equal to, so A4 is minus 7.2 minus A3 is minus 5.2, that is minus 7.2. So here minus into minus plus 5.2, again we can get minus 2.0. So student, here the common difference is equal in each successive terms. So therefore it forms an AP. It forms an AP. It forms an arithmetic progression. Therefore common difference. What is the common difference? Common difference small d is equal to minus 2.0. So next he is asking to find the 3 more terms. So here 1, 2, 3, 4 terms are there. 3 more terms. These are up to A1, A2, A3, A4. So 3 more terms are A5, A6 and A7. We have to find A5. So A5 is equal to, we can write A4 plus D. So we have A4 is equal to minus 7.2 plus D is minus 2.0. So this is D. So that is minus 7.2 minus 2.0, we can get minus 9.2. So in the same way, we have to find A6 is equal to A5 plus D. A6 equal to A5 plus D. So we have A5 is equal to minus 9.2 plus D is minus 2.0, that is minus 9.2 minus 2.0, it is minus 11.2. So this is A6 and A7 is equal to we can write a6 plus d. So again we have a6 is equal to minus 11.2 plus d is 2.0. So we can get minus 11.2 minus 2.0 minus 13.2. So just we have to add a common difference to the preceding term, student. Therefore the three more terms are the three more terms are minus 9.2 comma minus 11.2 and minus 13.2. so these are the three more terms. So next, this is the fourth one, student. Again we have to check whether the given series forms an AP or not by finding the common difference of successive terms. So again we have to find. How can we find? So we have to check a2 minus a1 is equal to a2 minus a1 is equal to. So a2 is minus 6 minus a1 is minus 10, student. So that is minus 6 minus into minus plus 10, which is 4. So a2 minus a1 is equal to 4. In the same way, you have to find a3 minus a2. a3 is minus 2 minus a2 is minus 6. So we can minus 2 minus into minus plus 6. Minus 2 plus 6 is 4, student. In the same way, you have to find a4 minus a3. So a4 is 2 minus of a3 is minus 2. 2 minus of minus 2, it becomes 2 plus 2, which is 4. So here also common difference is same. Therefore it forms an AP. It forms an AP. That is arithmetic progression. Therefore he is asking to find us the common difference. Therefore common difference D is equal to how much, student? Common difference is equal to 4. So he is asking to find us the next 4 terms. So that is a5, a6, a7. So a5 can be written as a5 is equal to a4 plus d. So we have a4 is equal to 2 and d is equal to how much? 4. So 2 plus 4 is 6. In the same way, a6 is equal to a5 plus d. a5 we have 6 plus d is 4. 6 plus 4 is 10. So next, a7 is equal to a6 plus d. a6 is 10 plus d is 4. It is 14. So these three are the three more terms. Therefore we have to write three more terms are 6, 10 and 14. So these are the three more terms of the given AP. So this is the fourth bit. Student, next we have to solve fifth. Student, this is the fifth bit in the fourth problem. Again he has given a series. Now again we have to check whether it forms an AP or not by finding the common difference of the successive terms. I am finding a2 minus a1 is equal to. So a2 is 3 plus root 2 minus a1 is 3. So minus 3 plus 3 gets cancelled, student. It is a root 2 we can get. So in the same way, a3 minus a2 is equal to. So a3 is 3 plus 2 root 2 minus a1 is 3 plus a2 is 3 plus root 2. So just we have to simplify, student. 3 plus 2 root 2. So by multiplying minus, we can get minus 3 minus root 2. Minus 3 plus 3 gets cancelled. 2 root 2 minus root 2 is root 2. So next to a4 minus a3 is equal to. a4 is 3 plus 3 root 2 minus a3 is 3 plus 2 root 2. So again by simplifying, it is 3 plus 3 root 2 multiply by minus, it minus 3 minus 2 root 2. So plus 3 minus 3 gets cancelled. 3 root 2 minus 2 root 2 is root 2 again. So in all the successive terms the common difference is same. Therefore it forms an AP. It forms an AP. So common difference equal to, what is the common difference, student? Common difference is equal to root 2. So next he is asking to find us three more terms, a1, a2, a3, a4. So next a5 is equal to a4 plus d. So we have a4 3 plus 3 root 2, 3 plus 3 root 2 plus d, that is root 2. So it becomes 3 plus 4 root 2. So 3 root 2 plus root 2 is 4 root 2. So next a6 is equal to a5 plus d. a5 we have 3 plus 4 root 2 plus d is root 2. So we can get 3 plus 5 root 2. 3 plus 5 root 2. So next a7 is equal to a6 plus d, that is 3 plus 5 root 2 plus root 2, which is 3 plus 6 root 2. 3 plus 6 root 2. So therefore the 3 more terms are 3 plus 4 root 2. We can write therefore 3 more terms. 3 more terms are, so what are the 3 more terms? 3 plus 4 root 2, comma 3 plus 5 root 2 and 3 plus 6 root 2. So these are the 3 more terms, student. These are the 3 more terms. So next we have to find 6th bit. So 0.2, 0.22, 0.222, 0.2222 and so on. So again we have to find the common difference. a2 minus a1 is equal to, that is 0.22 minus 0.2. So that is it is 0.02 student, 0.02. So next a3 minus a2 is equal to, a3 is 0.222 minus a2 is 0.22. So here it is 2 cancel. Here if you write 0, we can get 0.002. So here a2 minus a1 is not equal to a3 minus a2 student. These two are not equal. Therefore it does not form an AP. It doesn't form an AP. It doesn't form an AP. So this is the 6th bit, student, in the 4th problem. Next we have to solve 7th. Student, this is 7th bit in the 4th problem. 0, minus 4, minus 8, minus 12 and so on. Again we have to find whether it forms an arithmetic progression or not by finding the common difference of successive terms. So I am finding a2 minus a1 is equal to, a2 is minus 4 minus a1 is 0, that is minus 4. So next a3 minus a2 is equal to, a3 is minus 8 minus a2 is minus 4, that is minus 8, minus into minus plus 4, again we get minus 4, minus 8 plus 4 is. So next a4 minus a3 is equal to minus 12 minus of minus 8. So here a4 is minus 12 minus a3 is minus 8, that is minus 12 minus into minus plus 8, which is minus 4. So student, the common difference is same, therefore it forms an AP. It forms an AP. It forms an AP. So common difference how much, student? Common difference is equal to minus 4. Common difference is equal to minus 4. So next he is asking to find 3 more terms, that is a5, a6, a7. a5 is equal to a4 plus d. So this is a4 minus 12 plus d is minus 4. So that is minus 12 minus 4 is minus 16. So next a6 is equal to a5 plus d again. a5 is minus 16 plus d is minus 4, minus 16 minus 4, which is minus 20. So next a7 is equal to a6 plus d. a6 is minus 20 plus minus 4, that is minus 20 minus 4 is minus 24. So these 3 are the 3 more terms. So therefore 3 more terms are minus 16, minus 20 and minus 24. These are the 3 more terms. So this is the 7th bit, student. So next 8th bit in the 4th problem, student, minus 1 by 2, minus 1 by 2, minus 1 by 2 and so on. So student, again we have to check whether it forms an AP or not. Here A2 minus A1 is equal to minus 1 by 2 minus of minus 1 by 2. So here we can get minus 1 by 2 plus 1 by 2, which is 0. So in the same way we can get A3 minus A2 is also 0, student, and A4 minus A3 is also 0. So all are minus 1 by 2 only. So therefore the common difference is same. It forms an AP. It forms an arithmetic progression. So he is asking to find us 3 more terms. So all are equal. So 3 more terms are also. So 3 more terms are. 3 more terms. So here all are minus 1 by 2. They are also minus 1 by 2, comma minus 1 by 2 and minus 1 by 2. So these are the 3 more terms. So this is the 8th bit, student. Next we have to solve 9th bit. Student, this is 9th bit in the 4th problem. 1, 3, 9, 27 he has given, student. Again you have to check whether it forms an AP or not by finding the common difference. A2 minus A1 is equal to 3 minus 1, which is 2, student, and A3 minus A2 is equal to 9 minus 3, it is 6. Therefore here A2 minus A1 is not equal to A3 minus A2. So the common difference is not same. Therefore it doesn't form an AP. It doesn't form an AP. It doesn't form an AP. So if it forms, you have to find 3 more terms, but it doesn't form an AP. So next 10th bit, student. A, 2A, 3A, 4A and so on. So again you have to find common difference. A2 minus A1 is equal to 2A minus A, which is A. So next A3 minus A2 is equal to 3A minus 2A, which is also A. So 3A minus 2A. So next A4 minus A3 is equal to 4A minus 3A, which is also A. So the common difference is same in all successive terms. So therefore it forms an AP. It forms an AP, arithmetic progression. So he is asking to find us the common difference. Common difference is equal to how much, student? A. So next he is asking to find us 3 more terms. That is A5 is equal to A4 plus D. So A4 is 4A plus D is A. 4A plus A is 5A. So next A6. A6 is A5 plus D. That is A5 is 5A. D is A. 5A plus A is 6A. So next A7 is equal to A6 plus D. A6 is 6A plus A, which is 7A. Therefore 3 more terms equal to 5A, 6A and 7A. So these are the 3 more terms in the 10th bit, student. So next we have to solve 11th bit. Student, this is the 11th bit in 4th problem. So A square, A cube, A to the power 4 and so on. So he is asking to find whether it forms an AP or not. So A2 minus A1 is equal to A square minus A. That's all, student. We can take A as common. So A into A minus 1. So A3 minus A2 is equal to A cube minus A square. We can take A square as common. Here we can get A minus 1. But these two are not equal, student. Here it is A into A minus 1, but here it is A square into A minus 1. So A2 minus A1 is not equal to A3 minus A2. Therefore it doesn't form an AP. It doesn't form an AP. So this is the 11th bit, student. Next we have to solve 12th bit. Root 2, root 8, root 18, root 32 and so on. So student, again you have to find A2 minus A1. So a2 minus a1 is equal to root 8 minus root 2. So root 8 can be written as it is 4 into 2 minus root 2, root 4 into 2, that is 2 root 2 minus root 2 student, so that we can get root 2. So root 2 we can get 4 into 2. If you write 4 as it becomes 4, root 4 is 2 and root 2. 2 root 2 minus root 2 is root 2 again. So here a2 minus a1. So next a3 minus a2 is equal to root 18 minus root 8. So root 18 can be written as 9 into 2. Again root 8 can be written as 4 into 2. So here 9 into 2 it becomes 3 root 2. It becomes 2 root 2. So 3 root 2 minus 2 root 2 is again root 2 student. So next we have to find a4 minus a3. a4 is root 32. Root 32 minus a3 is root 18. Root 18. So it can be written as 16 into 2 student, and minus it can be written as 9 into 2 again. So 16, root 16 can be written as 4 root 2 minus root 9 is 3 root 2. So again we get a root 2. So in all the difference of successive terms is root 2 student. Therefore it forms an AP. It forms an AP. It forms an AP. So he is asking to find us the common difference. Therefore common difference is equal to root 2. So common difference how much student? Common difference is root 2 here. So next he is asking to find us 3 more terms. So common difference equal to root 2 student. He is asking to find us 3 more terms. That is a5 is equal to a4 plus d. a4 plus d. So we have a4 is equal to how much student? Root 32 plus d is equal to root 2. Root 32 plus root 2. So here root 32 can be written as 4 root 2 student plus root 2. 4 root 2 plus root 2 is 5 root 2. So it becomes, if you write 5 in the root, it becomes 25. 25 into 2 is root 50. Root 50. So next a6 is equal to a5 plus d. a5 is root 50 plus d is root 2. So student, this root 50 can be written as 5 root 2. So since 50 can be written as 25 into 2, root 25 is 5 student, that is 5 root 2 plus root 2. So it is 6 root 2. So again if you write, if you take 6 to the root, it becomes a 6 square. 36 into 2, that is root 72. So next a7 is equal to a6 plus d, that is root 72 plus root 2. Root 72 can be written as 6 root 2 plus root 2, which is 7 root 2. So student, just I am adding a7 equal to a6 plus d. a6 is root 72, d is root 2. So root 72 can be written as 6 root 2 plus root 2, that is 7 root 2. Again if you take 7 to the root, it becomes 49. 49 into 2, 98, root 98. Therefore 3 more terms are root 50, root 72 and root 98. So these are the 3 more terms in the 12th problem student. Root 72, root 50, root 72 and root 98. So this is the 12th bit student, and next we have to solve 13th bit. Student, this is the 13th bit in the 4th problem. This is the last bit student. Root 3, root 6, root 9, root 12 and so on. So now I have to check whether it forms an AP or not by finding the common difference of the successive terms. a2 minus a1 is equal to root 6 minus root 3. That's all student. So next a3 minus a2 is equal to root 9 minus root 3. So root 9 can be written as 3 minus root 3. So here these two are not equal, student. A2 minus A1 is not equal to A3 minus A2. Therefore, it doesn't form an AP. It doesn't form an AP. So if it forms an AP, you have to find the next 3 more terms, but it doesn't form an AP. So student, these are the 13 bits in the fourth problem. So student, now we have completed exercise 6.1. So total 6.1 exercise I have explained, student. You have to watch from first to last problem.